All right, so this is the right triangle review. So let me start here. So right triangle review. All right, so we have a right triangle here. We have two sides of the right triangle, and we're looking for the third side. So we're going to use the Pythagorean theorem. So we're going to use a squared plus b squared equals c squared, right? Leg squared plus leg squared equals hypotenuse squared. So the legs are the sides that are adjacent to the right angle. So that's what we're going to call A and B. It doesn't matter which one's A and which one's B, as long as they're the legs. And then your hypotenuse is the one across from the right angle, which is C. Okay, so this is going to be 4 squared plus x squared equals 10 squared. You could switch it and do x squared plus 4 squared equals 10 squared, same thing. So that's going to be 16 plus x squared equals 100. Okay, we can subtract 16 from both sides and you get x squared equals 84. And then we take the square root of both sides. That's 84. And we get x equals the square root of 84. Okay, and then we can simplify this. So we want to look for perfect squares that can go into our what's under the square root. So 84 can be split up into 4 times 21. And then that's going to give us 2 times the square root of 21. So we can put in 2 square root 21. All right, next question here. Again, we have two sides of a right triangle, so we're going to look for the third side, which we'll call x. So A and B are the legs, so A and B are going to be the 13 and the 10. And then C is your hypotenuse, which we're going to call x. So we have A squared plus B squared equals C squared. Okay, so that's going to be 13 squared plus 10 squared equals x squared. So it's going to be 169 plus 100, which is 269. Take the square root of that. Okay, square root both sides to get rid of the square. And you're left with x equals the square root of 269. And that cannot be simplified. So we'll leave it as that. Square root 269. Square root of 269. All right, next question talks about angle of elevation and angle of depression. So if you're looking out at a horizontal, like we are in both of these pictures, if you're above that horizontal, that's an angle of elevation. You're elevating it. You're going up. Okay. If you're looking below that horizontal line, that's an angle of depression. So this first one is an angle of elevation. So diagram 1, you're looking above that red horizontal line. And in diagram 2, it's an angle of depression because we're looking below that red horizontal line. So this would be the angle of depression. X would be the angle of depression. Y would be the angle of elevation. All right, the next one asks us to just describe which ones are the angles of elevation and which ones are the angles of depression. So we have 3 different horizontal lines we can draw in here. So we have the guy standing up by the restaurant. We have the guy in the middle on top of the observation deck. And then we have the guy on the ground. Okay. So the guy on the restaurant, he's looking, if he looks down towards the observation deck, that would be an angle of depression because it's below the horizontal. So 1 is an angle of depression because it's below the horizontal. Okay. If we're the guy on the observation deck and he looks up, right, that's going to be angle 2, and that's going to be an angle of elevation because he's looking above his horizontal line. Okay. 3, if he looked down to the ground, that would be an angle of depression because he's looking below his horizontal. So that's an angle of depression. And then 4, the guy on the ground, he's looking up. towards the observation deck, that would be an angle of elevation because he's looking above the horizontal. Okay, so 2 and 4 in this diagram are angles of elevation. 1 and 3 are angles of depression. All right, question 3 just wants the ratios. So if we remember, so katoa, SOH, DAH, then TOA, TOA. So sine, right, is going to be, so sine of an angle is going to be equal to opposite over hypotenuse. Right, and cosine is adjacent over hypotenuse. And then tangent here is opposite over adjacent. ADJ. Okay, so then we're just filling in the ratios here. We're looking at A. So we circle A and label our sides. So 5 is the hypotenuse, 3 is your opposite, 4 is your adjacent. So sine is opposite over hypotenuse, so that's going to be 3 over 5. Cosine is adjacent over hypotenuse, that's going to be 4 over 5. Tangent's opposite over adjacent, that's going to be 3 over 4. Okay, and then for B, we got to erase the hypotenuse stays the same. Okay, C is the angle we circle now, so 4 is now opposite of C, 3 is adjacent. So that's going to be sine of C is going to be 4 over 5. Cosine of C is going to be 3 over 5. And tangent of C is going to be opposite over adjacent, which is 4 over 3. The next one here. We're doing the same thing. We're just writing the ratios. Okay, so sine of n, so hypotenuse is 15. Across, so 12 is opposite. Adjacent is next to, so 9 is next to. Right? Sine is opposite over hypotenuse, so that's going to be 12 over 15. Okay, we have to reduce that so we can divide the numerator and the denominator by 3. 3 is the greatest common factor. So that's going to give us 4 over 5. Right? Cosine is adjacent over hypotenuse, so 9 over 15. Reduce it. That's going to be 3 over 5. Tangent is opposite over adjacent. That's 12 over 9, which is going to be 4 over 3. So 3 over 5, and then 4 over 3. Okay, when we do the other angle, we got to switch the opposite and adjacent. So now we're doing angle P. So across from angle P is 9. That's now opposite. And then 12 becomes adjacent. So sine is going to be 9 over 15. Cosine is going to be 12 over 15. And tangent is going to be 9 over 12. If we reduce those, we have 3 over 5, 4 over 5, and 3 over 4. Okay, so 3 over 5, 4 over 5, and 3 over 4. Okay, next one over here. Right, we need to solve for x. So we want to circle the angle, label our sides. 10 is across, so that's opposite. X is next to, so that's adjacent. So we have opposite and adjacent, so we're going to use tangent. So the tangent of the angle, we input the angle measure, so tangent of 42 equals opposite over adjacent. So opposite is 10, adjacent is x. Then we solve for x. So we want to multiply both sides by whatever's in the denominator. We're trying to get x by itself. Okay, that's going to give us x times tangent 42 equals 10. And then we can divide both sides by tangent of 42. Okay, so x is going to be 10 divided by tangent 42. If we put that in the calculator, we're going to put in 10 divided by, make sure you're in degrees, and then we're going to put tangent 42. And that's 11.1. They want thousandths place, so that's 3 decimals, so 106, 11.106. The next one, okay, we are going to circle the angle, 37 degrees, label the sides, 10.3 is the hypotenuse, x is opposite, so opposite and hypotenuse, that's going to be sine. So we input the angle into the sine function, so sine of 37 equals, and then the output is the ratio of the opposite over the hypotenuse, so x over 10.3. We're trying to get x by itself, so we're going to multiply both sides by 10.3. So x is going to equal 10.3 times the sine of 37. Okay, and then if we put that in the calculator, 10.3 times, make sure you're in degrees, sine of 37, and that's going to be 6.199. Okay, next one here. Okay, so we're going to circle the 47, whoops, circle the 47. 3 is the hypotenuse, x is the adjacent, so it's going to be cosine. So we're going to do cosine, you input the angle measure, 47, and the output is the ratio of the adjacent over the hypotenuse, so that's x over 3. And then we can multiply both sides by 3 to get x by itself. So 3 cosine 47. Right, put that in the calculator. 3 cosine 47. Make sure in degrees, and that's 2.046. 2.046. Next one here. Okay, now we're solving for the angle, so we got to use the inverse functions. Okay, so if you're solving for a side, you use the regular trig functions, sine, cosine, tangent. If you're solving for an angle, you got to use the inverse sine or inverse cosine or inverse tangent. Okay, so sine inverse, opposite over hypotenuse. Okay, equals the angle. Cosine, inverse cosine, if you input the ratio adjacent over hypotenuse, that'll give you an output that is the angle. And then inverse tangent, if you input the ratio of the opposite side over the adjacent side, the output of that function will be the angle. So it's adjacent, ADJ. Right, so we circle the angle, label the sides, 44 is your hypotenuse, 39 is opposite, it's across. So we're going to use inverse sine. We input the ratio, 39 over 44, and the output is the angle measure. So we go over to the calculator. Well, this one they want us to first put in inverse sine. So sine inverse, we're putting in 39 over 44. Right, and we can put that in the calculator. Make sure you're in degrees. You click the inverse button here on the left. Inverse sine 39 divided by 44, 62.420, right? We got to round the 19 up to a 20, so 62.420. Right, and then the next one here, again, we just want to circle the angle, label the sides. 36 is hypotenuse, 24 is adjacent. So we're going to use cosine, so inverse cosine. Then you input the ratio, right? Adjacent over hypotenuse, so 24 over 36. That's going to give you the angle measure. So we can do cosine 24 divided by, you could reduce that to 2 over 3 if you wanted, but inverse cosine 24 over 36. And that's going to give us 48.190, 48.190. Right, number 12 here. So we need to find the other two sides. So what I'm going to do is circle the angle. So we're solving for sides, so we're going to use regular trig, sine, cosine, or tangent. I'm going to label this side x and this side y. Okay, and the y is the hypotenuse. The x is the opposite of our angle, and then 3.5 is our adjacent. So to solve for x, we're going to use opposite and adjacent, right? The one we're solving for in the number. So that's going to be tangent. So tangent, input the angle, 55, equals the ratio of the opposite over the adjacent. So x over 3.5. Then we're going to multiply both sides by 3.5 to get x by itself. So x is going to be 3.5 times the tangent of 55. Make sure you're in degrees. And 5.0. That's going to be 5 point, and that's AC, 5.0. All right, the other one here, we're going to use the hypotenuse and the adjacent. So that's going to be cosine. So cosine 55 going to equal the adjacent over the hypotenuse. So that's 3.5 over y. We want to get y by itself, so we have to get it out of the denominator. So we'll multiply both sides by y. And then we can divide both sides by cosine of 55 to get y by itself. So divide by cosine 55. Right, so y is going to be 3.5 divided by cosine of 55, which is going to be 6.1. Last one here is find the measure of the angles. So we're going to use the inverse trig functions to find the measure of the angles. So I'm going to call this x and this y. Okay. To solve for x here, let's label. So hypotenuse, 7 is adjacent. So we're going to use cosine. So inverse cosine. We're going to input the ratio, adjacent over hypotenuse, 7 over 14. And that's going to equal x, which is the measure of angle B. So we're going to go to our calculator and we're going to put in inverse, make sure your degrees, cosine 7 divided by 14. That's going to be 60 degrees. We know the three angles of a triangle add up to 180, so we can do 180 minus 90 minus 60, and that's going to give us 30 for the other one. If you want to solve that out, though, using trig, we would relabel. The 7 is opposite. Whoops. So 7 would be opposite for y. So if we're solving for y, 7 is opposite. Right, so you'd use sine. So it'd be inverse sine 7 over 14. So inverse sine 7 over 14. Inverse sine of a half, which we know is 30 degrees. Okay, and that is the right triangle review.